Hi, and in this tutorial we're going to find the trig values for non-special angles. So sometimes we'll have a situation like this. We have if the sine of theta is equal to 4/5 in quadrant 1, then find the other 5 trig function values. Obviously we have one of them. We have the sine value. I'm looking for the other 5. So ultimately I'm looking for the sine of theta, which I know we already have, the cosine of theta, the tangent of theta, and then their reciprocals, cosecant of theta, secant of theta, and cotangent of theta. I'm looking for all 6 of these values. Now we already know we have one of them. We have the 4/5. So the sine of the sine is equal to 4/5. And since we know that, then we also have the reciprocal of that because that's not too difficult. Okay, great. So we have 5/4. We need to find the other 4 trig values. Now, this is not one of our special sign distances. This is not one of the distances on the unit circle. There's only 5 on the unit circle. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And of course all their opposites. 4/5 is not one of them. So we're really not talking about one of our special angles. Theta is not one of our special angles. So we need another way to attack this problem. And I just simply call this a triangle problem. I'm just going to draw a triangle and use SOHCAHTOA. I know that we're drawing an angle in quadrant 1, so I don't really care what the angle looks like. I literally just always draw a 45-degree angle. And the triangle will always be made to the x-axis. I always have to make a right triangle, and from my angle, from my terminal side, the triangle is made to the x-axis, not to the y, to the x-axis. Okay, so there's theta, or at least there's a picture of theta. Now we just need to label some sides. If they give me a sine ratio, they're going to have given me 2 sides of a right triangle. And I remember my SOHCAHTOA. And since they're giving me the sine ratio, I know that they're giving me the opposite side and the hypotenuse. So that must mean that from where I'm standing, and I'm always standing at the origin, the sine ratio is the opposite side divided by the hypotenuse. So that must be 4 divided by 5. So I'm just going to draw a quick picture of a triangle. That's why I call it a triangle problem. And make the opposite side 4 and the hypotenuse 5. Because therefore, my sine has to be 4/5. I could use other numbers that reduce to 4/5, but I'll just go ahead and do that. So now I just need to figure out what's my missing side. My missing leg is right here, and I know most of you already know that it's 3. You could use your Pythagorean theorem to prove that. 5 squared is equal to 4 squared plus, I'll call it x squared. Of course, 25 is equal to 16 plus x squared. Subtract your 16, and now we have 9 is equal to x squared. So therefore, x is equal to 3. Not -3, because that doesn't make much sense unless we're going in the negative direction. Okay, so 3, 4, 5. And since we're here, obviously, hopefully you knew that that was one of the Pythagorean triples. 3, 4, 5 is one of the famous right triangles. One of my go-tos is right there, 3, 4, 5. The next one I like is 5, 12, 13. That's also a Pythagorean triple. 5 squared plus 12 squared does indeed equal 13 squared. 8, 15, 17 is another one that I like to use. Obviously the numbers are getting bigger, but 8 squared plus 15 squared will equal 17 squared. I believe 90, 40, 41 is one that I've remembered, and 11, 60, 61. I don't tend to use those so much because those are bigger numbers, but these are my 3 main ones. If you want to memorize those Pythagorean triples, it might save you some time so you don't have to use Pythagorean theorem every single time. Okay, once you have a picture, again, I don't know what theta is. I just know that it's in the first quadrant. But once you have a picture, it's pretty simple, and you just have the 3 ratios. You just need to remember sine, cosine, and tangent. We've got the sine and its reciprocal. Cosine is adjacent over hypotenuse. Adjacent, therefore, is 3, adjacent to where you are. Adjacent is 3, and of course the hypotenuse is still 5, so there's 3/5, and that reciprocal is 5/3. And then tangent is opposite. Let's go to the TOA. It's opposite over adjacent, so that's the 4 divided by the 3. And of course, the reciprocal of that is 3/4. So there's our answers. Those are all the trig values. We were not given one of our special angles, but that didn't mean we couldn't solve the problem. We were given enough information to draw a nice little right triangle. We drew it where it needed to be, and we labeled the missing side. And then we've got all of our trig ratios. We just need to remember SOHCAHTOA and the reciprocals. So here's our final problem. The terminal side of beta contains the point 8, -15. Find all 6 trig values for beta. Okay, so we've switched our angle from theta to beta, but we're still doing the same thing. I need to find sine of beta. I need to find cosine of beta. I need to find tangent of beta and their reciprocals. I like to write them all in the same exact order every single time. It helps me to remember which ones are reciprocals of which ones. So I need to find all those. Unfortunately, I didn't even get any of these 6 this time. So I'm still going to draw a picture. 8, -15 I know is not in the unit circle because that would be a much bigger radius than 1, but I can still draw where 8, -15 is. 8, -15 I guess is approximately right there. And I can draw an angle that goes through there. In this case, we're in the 4th quadrant. And I'm just going to make a triangle. Always to the x-axis, my right triangle. So here's where I am. Here's where beta is. This is always where I'm standing on the origin. And I need to label some of my sides. And I know them because if it's 8 units to get out this way, then that must mean that this is a distance of 8. And if it's 15 units to get down here, then that must mean that this is a distance of 15. I do need to know that this is a negative distance though, because we are indeed going down. So now the only one that I'm missing is my hypotenuse. You can go and do your Pythagorean theorem and say that 8 squared plus 15 squared, or -15 squared, doesn't matter, when you square it, it's going to be positive, and then take the square root, but I know that 8, 15, 17 is one of my Pythagorean triples that I just showed you. So I can save some time. And now I've got a complete picture of a right triangle. I'm going to go back to SOHCAHTOA, and I'm going to get all of my ratios. Let's start with the sine. Opposite over hypotenuse. Opposite to where I am is -15. The hypotenuse is 17. So this is -15 over 17. The reciprocal to that, always keeping the negative in the numerator, please, is -17 divided by 15. I always like to float the negative into the numerator. Let's go to the ka. Ka is cosine. That's adjacent over hypotenuse. That would be the 8 divided by the 17. So that's 8 divided by 17. And of course, the reciprocal of that is 17 divided by 8. And finally, my last one, my toa. That's going to be, again, I'm standing here, opposite over adjacent. That's -15 divided by 8. So there's -15 divided by 8. The reciprocal of that, I'm going to keep the negative up top, -8 over 15. And that's how we would solve something like this. Again, I know that I'm not on the unit circle because the unit circle has a radius of 1, and this radius is actually 17. Okay, the unit circle would be somewhere right around in here. But it's still an angle that cuts through the unit circle. It's just not one of our special angles because none of these distances are special distances that we're going to have memorized. But we were still able to do the problem. I have one last thing to show you, and it might be a helpful little trick to remember where what the signs are of our basic trig values. This is just a hint. Some people remember this. They say all students take classes. ASTC. All students take classes. And you have to go the same order as you would your quadrants. What this represents is all of them are going to be positive in the first quadrant. The sine is going to be positive in the second quadrant. The tangent is going to be positive in the third quadrant, and the cosine is going to be positive in the fourth quadrant. So we're talking about the sine, cosine, and tangent. All 3 of them are positive in the first quadrant. Heck, everything is positive in the first quadrant. The only one that's positive in the second quadrant, though, is sine. And of course, it's reciprocal, cosecant. but we're just talking about the main three right now. Tangent is the only one that would be positive in the third quadrant because that's a negative divided by a negative. And cosine is the only one that's positive in the fourth quadrant. So all students take classes is maybe a nice little trick to remember where things are positive and they'd be negative everywhere else. All right, thanks for watching this tutorial. I'll see you in class.